Okay, this is OCR Mathematics GCSE Paper 1 for January 2011. That's what I'm doing. We have 2 hours of this. I'm going to work through it quite quickly in the hope that you'll actually bother to look at it and see what you need to do. First of all, formula sheet. Don't try and answer them. You may come back to them. Question 1. Pictogram shows the favourite sport of each person at a youth club. Need to read it here. The key represents the gap there, people. Looking a bit confusing. Question A. Football is the favourite sport of 20 of the people in a youth club. So football, 1, 2, 3, 4, 5 is worth 20. So each one of those must be worth 4. So let's put a nice big 4 in there. How many people chose cricket? 4, 8, 12. 12. 2 people chose swimming. Well, I'm going to need a half to make it clear on the end there. That's a half. The pictogram is now complete. How many more people chose football than hockey? Well, if I look back to the top, 1, 2, 3 whole squares, so that's 4, 8, 12, plus another half that was missing from there. 12 add 2 would be 14. So let's write 14 in here. Which is the most popular sport? Well, clearly the most popular sport is going to be football. So most people are saying that. And then, how many people are there all together in the youth club? Okay, well, assuming they all answered. 1, 2, 3, 4, 5, 20 people. 4 and 2 is 6. That's another 12. And another 12. And we know that's 2. Let's add those up. 24, 26, 32, 52. And I've just written 52 down the bottom there. We need help with pictograms. Master Watch CD number 42. Question 2. In October 2008, India sent a spacecraft to the moon. The spacecraft weighed 1,304 kilograms. Write 1,304 using figures. 1,304. Units, 10, hundreds, thousands. The rocket was 143 feet high. What is the value of the 4 in the number 143? Its value is 40, or you could write 40 like that. In the exam, just choose one way. The rocket weighed 294,000. Well, I know that's thousands there, so it's 294,000 kilograms. Write 294,000 using words. So it's 294,000 kilograms. There we go. Okay. The rocket fired for 771 seconds. Right, 771, closest to the nearest 100. Well, here I've got 700, so it's between 700 and 800. Just to visualise it. If you're going to play with the tails, I'll talk to you in a minute. And 800. Clearly the halfway mark would be 750, so in this case I'm nearer to 800. So 800 goes in there. Write 771 seconds in minutes and seconds. That's quite a tricky question. I'm going to go for the fact that I know that 600 seconds would be, well, 60 seconds is 1 minute, so 600 would be 10 minutes. I've still got another 171 seconds to go, Well, 120 of those would be 2 minutes, leaving me with a further 51. So I'm going for 12 minutes and 51 seconds. The development of the rocket took 2 years. How many weeks are there in 2 years? Well, in 1 year there are 52 weeks, so in 2 years there'll be 104. The first manned flight to the moon was in 1969. How many years is it from 1969 to 2011? Well, my way for doing that, I'm going to say 1 year up to 1970, then 1980, 1990, 2000, 2010. I'm going to count those on my fingers now. I'll do it again. 1970, 1980 is 10, 1990 would be 20, 2000 would be 30, 2010 would be 40, so 2011 would be 41, plus the one I originally had from 1969, that's another 1, gives me 42. Okay, Gemma works part-time in a car showroom. Her pay in pounds is worked out by multiplying the number of hours she works by 8, then adding 50 for each car she sells. Last week Gemma worked for 11 hours but sold no cars. How much was her pay? Write down your method. 8 times 11 equals 88. £88. Gemma worked 7 hours and sold 2 cars. How much is her pay? So I want 7 times 11 plus 2 times 50. 7 times 11 is 77, 250 is 100, total of £177. Notice I put those 2 separate bits in there for my workings. It's 2 marks. I just don't want one answer. I better pick up some method marks there somewhere. 1 week, Gemma earned exactly £330. She worked a whole number of hours. Work out how many hours she worked and how many cars she sold. Well, I know she worked a whole number of hours, so I'm thinking now that it's got to do something with 11 and 330. There's a 330 in there. 330, that will be 8 hours. I'm thinking of a way to do this quickly. I'm going to go for something that ends in a 0 times by 11. So 10 times 8 hours would be 80. That's nowhere near enough. Let's do 20 times 8 hours would be 160. It's got to be something that ends in either an 80 or a 30, the answer here. Okay, I was struggling with that, so I paused it to have a think. I ended up thinking if I did 330, if I took off 50 first of all, that gave me 280, and I can share that by 8. Half would be 140, half of that is 70, half again is 35, so 35 hours, which is about the right number of hours to work a week. 1 car sold. That's the 50 I took off from the start. Okay, I've also filled in these. Write down a correct metric unit to complete these sentences. Now, metric units are millimetres, centimetres if you're doing length. If we're doing weight, it's grams, kilograms, etc. And if we're doing area, it's centimetres, millimetres. So a door is about 2 metres, my finger is 72 millimetres long, and a dinner plate weighs around 800 grams. The area of a postage stamp, well, I reckon that was about 2 by 2, 2 by 3, so I went centimetres squared. Okay, and again, sorry about struggling with that question. Okay, what is the mathematical name for the shape above? Underline the correct word in the list. Well, it's not a rhombus, it's not a pentagon, because a pentagon is 5 sides, so I don't need that one. I don't need that one. It's not a trapezium, it must be a quadrilateral, so let's underline it and make it really clear. Mark an obtuse angle on the shape above, label it O. So I need an angle that is more than 90, but less than 180. Now, I'm not quite sure about that one in there, but clearly that angle there is, so I'm going to call that one there O. Mark an acute angle. Now, acute angle has got to be less than 90, so that there I'm going to write as acute. Okay, next question. Put a tick inside each of the 2 triangles that are congruent. Congruent means exactly the same. So I could get a sheet of tracing paper in the exam, lay it over, trace my shapes out and see which match. I'm just going to do this one here for you. I know it's these 2 here. You can just see by going round, that isn't going to fit, that won't fit, that won't fit, but actually that one there does fit. So that's the one I want. Now notice it says put it inside. The reason it's saying put it inside is so it's clearly which one we're defining. If I put it outside, they may be thinking this one or that one. Question C. This is the net of a shape. What is the mathematical name of the solid shape? Well, net is the unfolded pattern, if you like. If I fold that up, I'll get a cube. I'm just going to write cube in there. Okay. A minibus can hold a maximum of 14 passengers. What's the largest number of passengers that can travel in 8 of these minibuses? Well, in each one there are 14, so it's going to be 8 times 14. There are different ways of doing this. Because it's timesing by 8, I like doubling, doubling and doubling. So I'm going to start my 14, double it is 28, double 28 is going to be 54, double 54 is 108. You could just do your 8 times table, you could do 56, add 56, I've got that wrong, let's toggle got it wrong. Double that should be 56. Let's cross that out again and go for double 56 should be 112. That's more like it. 112, 1, 1, 2. Sorry about that mistake. I was doing doubling and doubling. I doubled incorrectly. My other strategy was to know that 8 times 14 is the same as 8 times 7 times 2. And I knew that was 56. And that's when I realised I made a mistake. Times it by 2 is 112. That lesson there in checking the answer, really, isn't there? I thought I was right. I thought try another strategy to check if I'm right. Lucky I was. A roller coaster, 6 people travel in each carriage, 102 people went on the roller coaster at the same time. How many carriages would be filled? This is a division question. We basically want 102 divided by 6, or 102 divided by 6, or how many 6s in 102. I'm going to use some key markers for that. I'm going to do my 1, 2, 5, 10 and 20 markers to get me started. But 1 is just 6, 2 would be 12, 10 would be 120, so 5 are going to be, 20 would be 120, that would be 60, so that's 30. Now let's use these numbers to get up to 102. So 20 is 120, that's clearly too many. So let's not use that one. Let's go for 10, it's going to be 60. Another 5, well, so I just said would be 30. So far I'm on 90. Running total there are 90. I need another 12, so that's 2. That would take me up. So another 12 there gives me a total of 102. So I've got 10 and 5 and 2, 17. You may like to do revision the other way. I very rarely see this now. I don't like it as a method personally. I'll try and remember how to do it for you. How many 6s in 1? None. Carry the 1. How many 6s in 10? 1. 4 left over. How many 6s in 42? 7. If you like that way of division, use that way, that's absolutely fine. I prefer this way because I understand where it comes from. Question number 7. A, B, C, D, E are 5 events. Show the probability of each event by writing its letter above the correct arrow on the probability scale. The first one's done for you. You will not need all the arrows. Crucial there, we don't need all the arrows, it says. Okay, getting a 1, 2, 3, 4, 5, 6. Well, that's going to be certain, so that's what that's there. Getting a head when you spin a fair coin. Well, that's 0.5, half chance, so that's going to be there. Getting a 1, 2, 3, 4, 5 when you roll a 6-sided dice. Well, that's nearly all of them, so it's going to be towards the top, so C is going in there. My maths teacher growing to a height of 23 metres. Well, maths teachers are generally great and giants in the teaching world, but they're not ever that tall. So that's going to have to be 0 chance, which is going to be D. Getting a blue when you spin this fair spinner. So there are actually red, green, blue, 3 sides, so it's about a third, which is a bit more than halfway between a quarter. So yeah, I'm going for this one here. It's about a third, that would be a quarter, that's a half, so a third's going in there, and that was letter E. Number 8, draw the lines of symmetry on this shape. Okay, you should be doing this as a ruler. Clearly there is a mirror line there, and you could again use a piece of tracing paper to see if that's going to work for you or not. Flip it over and see. I can't see. Oh, there'd be another one that would be straight down the middle here. You should be using a pencil to nix on it and a green pen so it stands out clearly on the video. Copy and complete this diagram so the dashed line is a line of symmetry. Well, one way to do that would be to get your tracing paper, trace it, and then just flip it over. That's the way I would like you to do it in the exam. I've done that, and then you can trace it out. I'm now going to draw where that was. I'll just about remember that, and again you really ought to be using a ruler, but just for speed now I'm going to do it freehand so I don't spend ages showing you how to do it. There we go. C. Work out angle E, give a reason for your answer. Well, all angles on a straight line have to be 180 degrees, so whatever my answer is going to write here, angles on a line sum, that means add up, to 180 degrees. So a little bit of workings here, 105 and my 35, 140, you just count on it wherever you like, so I need another 40 to get me up to 180, so that's going to be 40 degrees. Okay, that's the staples, we're halfway. Copy and complete these sentences with reasons. F equals 50, well, it's a quadrilateral, that's 90, because angles in a quadrant at around 360 degrees. That's all they want. The next one, G equals 66, because opposite angles are equal. Sorry, couldn't see that. There we go. Right, next one. A survey of 180 police officers had their weight and height measured. This pie chart represents the number of police officers in each of the 4 categories. Right, this should be a circular pie chart. On my screen at the minute it's not, and it's to do with the fact that I've got a wide screen here, not a normal aspect screen. Hopefully it'll be something similar for yours. Sorry, just lost the screen there a minute, we're back again. Don't know what happened there. Here we go. In a survey, 180 police officers, the pie chart represents the number of police officers in each of the 4 categories. So we've got U underweight, normal weight, overweight, and obese. The angle marked for obese is 120 degrees. What fraction of the police officers in the survey were obese? Give your answer in its lowest terms. I love these questions because they really are so simple. It's 120 degrees out of the total of 360 degrees. So that's the same as 120 over 360, which is 12 over 36. I can halve both of those to be 6 over 18. I can halve both of those again to be 3 over 9. And yet again, I can divide this by 3 to be 1 over 3. So I'm now saying it's a third. Looking at it, that's about a third of a pie chart. So my answer here clearly is 1/3. How many of the 180 police officers were obese? So this is simple again, it's just a third of 180. So 180 divided by 3. If you're struggling with that, let's do 18 divided by 3. 3 6s are 18, so 3 60s would be 180. 60 officers. Again, I don't think I showed you that. Measure the angle for normal weight. Right, I'm struggling with that because I didn't come home with an angle measure. I've got a bit of paper to try and do it instead. So you're going to line up the centre on the centre, and just here I'm lining it up there now. There, so it's coming around, that angle there is going to be more than 90, I reckon it's about 100, so I'm going to guess here on my answer sheet about 100. You'd have to measure more accurately to see exactly what it was with a proper angle measure. 100 degrees. 4 of the overweight W police officers lost weight, so they became normal weight. Maureen calculated that the angle for normal weight N would increase by 7%. Explain why the angle cannot change by 7%. Well, the reason for that would be that we've got 180 police officers, and each officer is 2 degrees. We've got 180 officers, so and 360 degrees in the whole pie chart, so each one's going to be 2 degrees. Each officer is 2 degrees, so can't increase by an odd number. Okay. Next one. Question 10. Minus 3 add 8. Negative 3 add 8. Best here to think of a number line. That's minus 3, minus 2, move it across a bit, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. So that minus 3, count up 8. 1, 2, 3, 4, 5, 6, 7, 8, 5. So often I see people not bothering to do that, and it makes the question so simple. Negative 3 times negative 4. Well, 3 times 4 equals 12. A minus times a minus, or a negative times a negative, is going to be a positive. So the answer is just 12, plus 12. Minus 50 divided by 5. 50 divided by 5 would be 10. And again, a minus divided by a plus would be a minus. Bad thing happens to a good person is bad. Minus. Okay, next one at the top here. Work out 11 squared. That's 11 times 11. 121. The cube root of 125. The cube root is what number times by itself and itself again. It gives you 125. You could start with 1. 1 times 1 times 1, 1. 2 times 2 times 2, 8. 3 times 3 times 3, 9, 6, 27. 4 times 4 times 4, 16 times 4, 64. 5 times 5 times 5, 5 times 5, 25 times another 5 is 125. That's the number I'm looking for. Go back to here, so that number was 5. 2 to the power 5, that means 2 times 2 times 2 times 2 times 2. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 again is 32. This shape is an ellipse. The formula E equals 3AB. E equals 3AB can be used to find the approximate area E of an ellipse. Use this formula to find E when A equals 5 and B equals 4. So the formula is E equals 3AB, which is 3 times A times B. A is 5, B is 4, 5 times 4 is 20, 20 times 3 is 60. You might want to write here 3 times 4 times 5. Find B when E equals 150 and A equals 25. So now I've got 150 equals 3 times 25 times b. So the first thing I'm going to do is b, divide it by 3, so I know that if I divide that side there by 3, 150 divided by 3 is 50, is going to be equal to 25b, so 1b must be 2. There we go. When a and b are equal, the ellipse becomes a circle with a radius r. The formula would then become E equals 3RR. Write 3RR more simply, well, R times R equals R squared, so it would be 3R squared. And you should know that because it's very near to pi r squared, and we sometimes use 3 as an approximation to the area of a circle. If you haven't got a calculator, you know it's about 3 times the radius squared, or pi times the radius squared, 3.14, sometimes. Okay. Complete the table for y equals 2x minus 3. So my x number times 2, take away the 3, will give me my y number. Now, as always, I'm not going to start with negatives. Let's start simple. 1 times 2 is 2, take 3 is negative 1. 3 times 2 is 6, take 2 is 3. Now the complicated one. Minus 1 times 2 is minus 2. Take away a further 3 should be minus 5. Okay, this is the one I'm least sure about, and you're probably least sure about. I'm actually quite sure of it, but I know you will be. So I'm just going to treat that one with a bit of caution. Now I'm going to plot my points. This is going up in ones, this is going up. It's saying on the grid, draw the line, straight line graph of 2x minus 3. So I know it's a straight line graph. If I couldn't do that bit there may be a cheat way. So 5, 7, that's 1 point. 3, 3, I thought was another point. 1 minus 1. Now I'll just join those 3 up a minute into a straight line. Be as accurate as I can. There we go. That's my line. And lo and behold, it's minus 1, minus 5. Now if I couldn't have worked that out, I could have done those 3 plots, then looked at what is it when it's minus 1. Use your graph to find the value of x when y equals 0. So y equals 0, look across to x, I'm guessing that's 1.5? 1.5. Okay, question 14. There's going to be some working out here. This is worth 5 marks, so I've got to do some thinking. Steve wins £600 in a competition. He gives a quarter of the money to Liz and a fifth of the money to Sam. So first of all, I've got to know what's a quarter of 600 and what's a fifth of 600. So I'm going to work that out now. A quarter, 600, if I halve it, that will go to 300. If I halve it again, that's 150. So a quarter of it is £150. Now, I've got to do 600 divided by 5, a fifth of it. That's quite hard. I'm going to have a different one. I know a tenth of it would be 60, and a fifth is 2 tenths, so 60, 120. So I've worked out 120 equals a fifth. Okay, so I've got those key bits of information now. It then says of the remaining money he gives 10% to charity. Okay, that's not too bad then. So I've got 600. I've got to take away 150 and then 120 and see what's left. I've done it as a column sum for you here. I don't like that because of the way it is. So I'm going to say 600, take 100 is 500, take 50 is 450, take another 100, sorry my computer's going to stop again, do it again for you. 600, take the 100 is 500, take a 50 is 450, take another 100 is 350, take off a 20 is 330. So we had £330 left. Of that, he gives 10% to charity. we've got 330, I need to minus 10%. Well, 10% is £33. So I've got 330 minus £33. We'll take the £30 would be £300. Take off £3 is 297 left. So Steve should have £297 left. Hope that was relatively clear. Quite a long, complicated question, that. Cool. And that was it. End of the paper. Wasn't expecting that so soon. Okay, sorry about the one or two little mistakes I made along the way there. Particularly with that question I found quite tricky. Right. I just want to go back to something here I didn't do very well. I tell my students all the time and I didn't do it. Use your graph to find the value of x when y equals 0. I really should have drawn in a line here, like so, and mark it off. If they'd asked me to find the value of x when y equaled 4, I would have on my graph, as normal, just like on the scatter diagram question, drawn a line across and read down like that to get it accurate. Then I would have done that. It was really hard to show when it was on that line there. Hope that's clear for that one. I'm sure I've made one or two mistakes. As I've done that, I've had a few interruptions from my kids as I've been doing it as well, which is lost my focus a little bit. I hope that's helpful for you. There you go. It's that paper done. Good luck. Hope you are able to do your paper equally well, particularly the one when you're actually in the exam.